Hello, my fellow thinkers. I want to take you on a journey into the fascinating world of quantum fields. It's a place where the fundamental building blocks of our universe exist, and where particles interact in ways that we are still struggling to fully comprehend. So, what are quantum fields, you ask? Well, to understand that, we need to first talk about classical physics. In classical physics, we have fields that describe physical quantities like gravity, and these fields are represented as functions of space and time. But in quantum physics, things get a lot more interesting. Quantum fields are the foundation of everything we see around us. They are a mathematical description of physical fields that obey the laws of quantum mechanics. Simply put, they are the way we describe the behavior of particles and their interactions with each other. The remarkable thing about quantum fields is that they exist everywhere in the universe, even in empty space. These fields are not still, they are constantly fluctuating, and they can interact with each other to create new particles. Let me give you an example of one such field that you may have heard of, the electromagnetic field. The electromagnetic field describes the behavior of photons, the particles that make up light. The field interacts with charged particles to create electromagnetic waves like radio waves, microwaves, and visible light. It's what allows us to communicate wirelessly, watch TV, and see the world around us. Another field that is crucial to our understanding of the universe is the Higgs field. In 2012, the discovery of the Higgs boson, also known as the God particle, was a monumental achievement for particle physicists. The Higgs field is responsible for giving particles mass, and without it, the universe as we know it would not exist. Quantum field theory, the study of these fields, is the basis for many of the most successful theories in physics, including the Standard Model of particle physics. The Standard Model describes the behavior of particles and their interactions through the electromagnetic, weak, and strong forces. But perhaps the most fascinating property of quantum fields is entanglement. When two particles become entangled, their quantum fields become linked. This means that any change in one particle's field affects the other particle's field, regardless of how far apart they are. This property of entanglement has enormous potential applications in fields such as quantum computing and cryptography. It could revolutionize the way we process information and keep it secure. So, there you have it, my fellow thinkers, a glimpse into the complex and intriguing world of quantum fields. It's a place where the rules of classical physics no longer apply, and where we can only begin to scratch the surface of what's truly going on. But it's a place that continues to captivate and inspire scientists around the world. Thank you for joining me on this journey, and I hope you'll continue to explore the mysteries of the universe with me in the future. If you like the video, do subscribe for more awesome content in the future.